Okay, guys, so we have covered the beginning of the unit, okay, in the day one video. We were talking about different forms of linear equations. That was slope intercept, standard form, and point slope form. Um, Again, the kind of focus here is on point slope form for this unit. Um, and that's just because, right, it's the focus. It's not the preferred one, definitely not for me. Slope intercept is the king. And then standard form would follow only because of its use in future units. Okay. So those two are preferred. Point slope is just a means to get to slope intercept for the most part. Okay. So we went through and we did a couple problems with point slope. Um, and we talked about how to convert from a linear equation in slope intercept form over to standard form. And we would just reverse that process to work backwards. So today we're going to kind of move a little further in linear equations, right? And we're going to talk about that middle part of the unit. So we're going to go back with unit for day 2 review, or unit 4 review, day 2, however you want to label it. Okay. And so we've been talking about equations in singular form. As far as lines on a graph, we've just been talking about one. And now we're going to move on to comparing, right? And the comparison will be parallel versus perpendicular. All right, so when we look at two lines, right, on a graph, those are very special relationships. Now, they can be neither of those two things and actually be intersecting lines just at some random angle, but very important, right? We have these two special relationships that we're being asked to evaluate. Okay, so as we look at these two relationships, we need to remember, right, what it means, right? Parallel, they have first, same slope, right? Different y-intercept, right? Same slope, different y-intercepts, which means, right, they're never intersecting. Okay, never intersecting. All right, so parallel just means, right, they're going to run at the same trajectory and never touch. Now, they can be positive parallel, they can be negative parallel, really doesn't matter. Just as long as, right, they are traveling in the same direction at all times, and those two lines would never intersect, okay? We could follow them to the edges of the earth, and we'll never find them any closer or any farther apart, okay? But the key here, right, is the same slope aspect, right? If we're asked about parallel lines, we need to make sure that their slopes match, okay? So in the case of these two lines, we're just going to make up some random equations. Maybe we'll call that line A has an equation of y equals, and we're going to call this a slope of, I don't know, it looks like maybe 3/4. It's definitely positive, and it crosses maybe, we'll say, at 5. Okay, and then line B, right, is going to have also definitely already know that is 3/4. Now, what the y-intercept is, I don't know, maybe it's a -2, right? Those look kind of comparable, but the real telltale is right here, right? That is what's going to tell me those two lines travel the same and are never going to intersect. Okay. All right. So we can then look at a perpendicular situation, right? And so perpendicular slopes are negative reciprocals.
Mr. Shea, can you stop by the front office, please?
All right, slopes are negative reciprocals. And if you'll remember what that means, right, that just means opposite sign and flipped. Okay, that's what that means, negative reciprocal. It does not mean, right, that the slope is always negative, right? That's not what the negative implies here. The negative here implies opposite. Okay, so these most certainly intersect, right? These intersect at exactly 90 degrees. Okay, they intersect exactly at 90 degrees. So when we look at a graph of these two lines, and again, not getting super specific with this, just going to go ahead and sketch out, right, what that would look like. Okay, so there's line A, and we're going to switch this, right, and we're going to go with line B here, right? And so we can say, bam, we have that 90-degree relationship with these two lines, right? And so how do we know? Well, again, line A, we're going to use that same equation. So if line A is y equals 3/4 x plus 5, okay, line B looks to almost go through the origin on this one. So we'll call it the origin. But more importantly, right, we have the slope being now the opposite sign. So was positive, it's now going to be negative, right? And we're going to flip it over. Okay. So we're going to call that one right there, right? It's going to go through the origin for us. So we're not going to have a y-intercept, right? Just to remind you, right, when you have that situation, right, there is that imaginary plus 0 out there that we don't write, okay? We don't write that, but it is there, okay? So that is our parallel perpendicular relationship. Anytime we're asked, to evaluate something, say, hey, let's go ahead and do an example, right? Example 1. Let's go perpendicular to, let's just make something crazy up, right? 2x minus 5y equals 15, okay? And passing through the point let's see. It's gotta have a x value divisible by 5. So let's just passing through the point -5, comma 3. That should work out for us, right? So example number 1, find the equation of a line, right, perpendicular to this line, okay, and passing through the point -5, 3. Okay, so we've got a couple of things we need to realize here. One is I don't yet have the slope. Okay, so I need to identify that. I know I'm going to be working with point slope, right? So I know I'm going to be working with this equation because, right, I've got an indication of slope. Perpendicular, right, is my indication of slope. And I've got a point. The only thing is I can't find slope through a standard form equation. So first thing I need to start out. First thing I need to start out with is trying to identify the slope, right? So on a side note, I'm going to convert this over. Now, earlier in the unit, we talked about some basically cheats here, right? If we knew the cheat, if we knew the trick to just go ahead and identifying slope out of standard form, we can use that, okay? But I don't like leaning on tricks because if you forget them, right, you've forgotten them and you can't just all of a sudden remember. So we need to know what do we need to do here. Well, we need to isolate the y variable, okay? So in the end, we want y equals by itself. So we need to move some stuff away. The first thing I'm going to do is move this 2x onto the other side. Okay, so moving 2x over here, I cannot take 2x from 15, so he just kind of bumps out, right? So what do I end up with? I have negative 5y equals negative 2x plus 15. And then I'm going to divide everything by negative 5 so that y is by itself. All right, so what do I end up with? Well, y equals positive 2/5 x minus 3, okay? Which is good, right? I've now got, right, an indicator of slope. All right, so that is my slope of this line, right? My slope here, right, is identified now as 2/5. Well, I need a perpendicular slope to that. Okay, so perpendicular to 2/5 would be, right, flip it over, change the signs, negative 5/2. So got that one wrong. Let's make that a 6 here for our point instead, because it needs to be divisible by 2. All right, so we're going to look ahead, right? Now I've got a point and I've got my perpendicular slope. I can go ahead and work this problem. I've got y minus 3 equals, right, negative 5/2 x minus negative 6. Okay, again, just cleaning up the signs is the first step. That always just helps me keep the arithmetic fairly simple. Now I can go ahead and do my distribution. So negative 5/2 x. And then a negative times a positive, it's going to be negative. I've got negative 5 times 6. It's negative 30 divided by 2, right? Negative 15. And then I've got adding the 3 to both sides as my final step. That cancels. And now I've got negative 5/2 x minus 12. Okay. And again, if I need this into standard form, okay, so slope intercept answer, right? And we want to go ahead and convert it to standard. So if you'll remember converting this to the standard form, we're going to focus on that number right there. We need to get rid of that fraction. So we're going to multiply everything through by 2. And so initially you end up with 2y equals negative 5x minus 24. Okay, and that was just to get rid of that denominator of 2. And then the last thing to convert to standard form would be moving the 5x right over here to the other side. So my standard form would be 5x plus 2y equals negative 24. If they wanted standard form, right, I have it. So these are the same. These two, same answer, different form. Okay, same answer. Same answer. okay, for that one in slope intercept versus standard, okay? And again, I just multiplied everything times 2 to everything is where we get, right, from one to the other. It's times 2 everything. So that's an example problem of what might be asked of you in regards to perpendicular versus parallel. Again, if it's parallel, we're going to do all the same stuff except for, right, this step right in here. If parallel, I don't need to switch it. I don't want to flip it. I'm going to use the same exact number given as slope, okay, for a parallel relationship. Okay, so last little bit to talk about here, guys. As far as linear regression, okay, linear regression. And we had within that, right, that is to get y equals mx plus b for data set, okay? You'll still use the provided calculator for you virtual students, okay? If you don't have one already, to use a TI Nspire, that is preferred. That's going to give you exactly what they're expecting on the test. The one online might be a little different, but it'll be close enough. But have that open for a resource, okay? But within linear regression, we had a couple of subtopics, okay? So we talked about the correlation coefficient, right? And that was our R value for the data set, right? So R value is in our data set. And that's calculated separate. It resembles slope, right? It will carry the same sign as slope. Okay, so if your slope of your linear regression is negative, well, you can expect your R value to be negative as well. But they're not the same, right? They're not, slope is not the R value. It must be between +1 to -1, right? You're going to have that range between +1 and -1. So the closer you are to either, right? The closer you are to either, the stronger you are. And there was a whole scale we talked about. Just know, right, that we're basically looking at a value that is more than 0.7, right? And up is strong, okay? 0.7 and up is strong. 0.7 and down in terms of negative, we're getting very, very weak, right? As far, or it's still a strong negative. Anything lower than 0.7, your correlation is weakening, and that means your relationship is, not quite there, right? You can still make a prediction, but it's not as strong, right? You're not going to have as much faith in your prediction. Okay. Remember, correlation itself, refers to a implied relationship. Okay, implied relationship. That means, right, we are making the inference that this will happen, but not quite always, right? It's not 100% fact, right? It's not a direct relationship. Where on the flip side, the other thing we introduced in this unit was causation, right? And causation, we don't calculate, right? Causation is based on data being collected and analyzed over long periods of time, or lots and lots and lots and lots of data being collected to a point where you can say one thing directly causes another. Okay. There is just facts to back it up, right? Or a clear relationship between it. So, you know, we can directly link those two things together. It's not a, well, that does happen, right? There's not a relationship there. It's not like saying, well, it's hot outside, so people wear shorts. Well, that's true for the most part, but not everybody wears shorts in the summertime. And furthermore, it's not always nice and sunny in the summertime for everybody. So it just depends on where in the world you are, right? So we can't say, right, that summertime is a direct cause of somebody wearing shorts. We can simply say that's a relationship. There's a correlation between people wearing shorts and it being summertime. Versus, right, my example again the other day would have been something like when it rains, right, the sidewalk gets wet. And or the grass gets wet, or the trees get wet, right? So that's a direct relationship, right? There's definitely a link between rain and the trees getting wet. So there's no doubt about it, right? It happens every time. And you know, that's based on observations. You know, you could collect data if need be, but every observation would yield the same result. All right. So if you have any questions, comments, concerns, please, by all means, give me a shout on Schoology, and I'll get back with you as quick as I can. If not, be looking for that CUA on Tuesday. Take your time. Make sure you've got all your calculators open and available to you so that you can easily navigate between them as needed. If you've got the Inspire, then you are good to go. Just make sure you review the videos on how to do linear regression, how to calculate your R value. And again, if you have any problems, let me know. Thanks, guys.